All right. Can y'all see that?
Yep. Whenever
All
you're
right.
ready.
Okay. I'm talking about OpenMP. OpenMP is a high-level declarative pragma-based, I don't know what to call it, thing that you can insert into your C code, your C++ code, your Fortran code, and it describes declaratively threading things for like, for example, if you have tight loops, and it's used primarily in high performance computing, but it's supported by compilers. It's created by a standards board that encompasses like Intel, HP, all the compiler writers. So what I'm going to show you right now is this is a C program that has OpenMP in it, and it is computing pi using some iterative method. And what I wanted to show here, otherwise it's a normal C program, but you've got these pragma heres that define where you would like the compiler to consider the parallel section to start. And then it does all the magic to thread it internally. There's a translation phase where if you have OpenMP enabled, the compiler will basically insert pthread calls, and that's what's normally used. GCC is most likely the most common avenue for everybody to try it. It's done through libgomp, so it's the GOMP, the GOMP, OpenMP library. So what I've got here, this is a C program that computes pi. This is another one. But what I want to show is an example where I'm actually using inline C, which is right here, and I'm utilizing this alien module for OpenMP. And what it is doing through this, I don't know how many people are familiar with inline C, but in any case, what I'm doing here is I'm defining that the C code is in the data section, which is at the bottom of this file here. And then with alien OpenMP, if alien modules include a, where is it? An inline, this is the alien OpenMP implementation. If inline C detects, or inline detects that there is a, or use it with some alien module or some other module, the inline module will call this inline method, and it's expecting basically the compiler flags that are required in order to compile some program. In this case, since OpenMP is enabled through the compiler itself, there's some flags that need to be inserted or passed on to, in this case, we're using GCC. Now the compiler flags, just real quick, in order to compile with OpenMP in GCC, you need to pass this -f OpenMP flag that tells GCC to look for those pragmas, and otherwise they're ignored as comments. This is providing the library, so libgomp for the linker phase of the compilation, and this is the header file that's required when you put it inside of a C program. There's equivalents for C++ and Fortran. Let me show you the make file that's actually, so the compilation of the C files, the C programs that I showed are under these two targets, pi and pi2. And this just shows if you were to compile command line through GCC, what it would look like, and the same thing here. What we're doing with the alien module is I'm compiling this subroutine to compute pi in a threaded fashion, and I'm running it through Perl. So let me run it in Perl before I run out of time here. Okay. So inline C was invoked, although I think I had it already cached, the shared library already cached, but it compiles that C code, and now it's accessing the subroutine or the function that I've defined here through this interface here, right here, pi. So down in the C code, I've defined pi. Now when it calls this pi function through the Perl script, this is actually threaded. So what this shows is a pretty concise example. If you wanted to create a set of subroutines through say inline C that were threaded, you could actually create a nice library and access multi-threading using OpenMP with some compiled code, and then access that through your Perl program. So I had some other things to show, but I think that's probably it. Anyway, look for Alien OpenMP. I also have OpenMP environment, which manages some other things with that. Anyway, happy to answer questions offline.